Hi everyone, in today's lesson we're going to talk about graphing square roots. So let's start with a parent function. Remember that a parent function is a basic graph of a function, the one that has not been moved or stretched or compressed. So we have seen these basic functions, lines, which is the basic function would be y equals x, so here it is. A square function where it's a parabola, otherwise known as a quadratic. Today our focus is going to be on a new function. It's called a square root function. Alright, so that's what we're going to be studying today, the square root functions. So before we do, let's refresh our minds on domain and range. Remember that domain is what x can be, in other words, the x values. Range is what y can be, in other words, the y values of the graph. So let's go ahead and practice this idea first. It says, given the following graph and table, state the domain, and then it even has a space for give the range. So we're going to do both of them. Now, domain, remember, is all the x values. So the question is, how far left and right does this graph go? Well, it goes to the right nonstop, and it goes to the left nonstop. Obviously, it's going up at the same time, but it's going to the left and right. And therefore, we can say from negative infinity to infinity. So there's no wall stopping and saying, you can't go any further than this. You know, it just slowly goes to the right and slowly goes to the left. Now the range is all the y values. So the first time I see a y value is really at 0, and then everything above that. So it's above 0, so we would say it's from 0 to positive infinity. So it's 0 and above. Alright, so we're going to be practicing that throughout the lesson. If you're uncomfortable with it still, that's okay. Let's get started. So basic square root function is y equals square root of x. That's the parent function. We're going to go ahead and graph some of these domains and ranges, or make a table so we can plot them. One way to do it is to use your graphing calculators so you can see the visual and then grab some points from the table. But since we're all together, we might as well just do this together. What I know is that if I put, a negative 2, square root of negative 2 is actually not a nice number. It's an imaginary number, so it's undefined, because I really don't know. I do know what the square root of negative 2 is. It's square root of 2i, but it's undefined. I won't be able to plot that point. So if I do negative 1 for the x, square root of negative 1 is all I, which is also undefined. It's not a real number. If I plot the point 0, square root of 0 is 0, so I have my first point on my graph, which is 0, 0. So I'm going to go ahead and plot that point. And if I have a 1, square root of 1, if I plug it in here, y ends up being 1 as well. So I have my second point, which is 1 and 1. Now, I can go ahead and pick 2 as my point, but the problem with that is I don't know what the square root of 2 is, but I do know the square root of 4. So I'm going to make x 4. And what is the square root of 4? Yes, it's 2. So we're going to go ahead and plot 4, 2. Now another number that you might have given me or thought about, and I'll just add it on here, could have been 9. What's the square root of 9? And that's 3. So we could have even another point right there, 9, 3. And this is what a square root function looks like. It is a parabola. It's half the parabola on its side. And then what we do is we ask for the domain. Well, the graph is going only to the right, and it starts at 0. So it's 0 and all the values to the right. So it's 0 and higher. So it's 0, comma, infinity is the domain. Notice that I do this bracket because 0 is part of the answer. Infinities always get these parentheses. Now for the range, we start at 0 and we go up as well. So once again, it's the same thing, 0 to infinity. So that's our domain and that's our range. Since we're going to the right this way and we're going up that way. Alright? So that's our parent graph, and we're going to kind of do some transformations to this parent graph. So let's keep going. Now remember that transformations just manipulate the graph. Alright? For example, we know that the starting point is going to come from the opposite of what we see. So I see a negative 8, so it's h. and from what we see outside. So those together is where we are going to start. And then we're going to look at our, quickly, the x minus h. Right? That controls our left and right. And notice and remember that it's always the opposite of what you think. So if it's positive, it's actually left. If it's negative value inside, then it's actually right. Okay, so it's always opposite. What you see on the outside, the plus k part, that controls up and down, and we do believe that. So if it's positive, it goes up. If it's negative, it goes down. So that makes sense to us. And then what's on the outside of the radical in front, that's going to help us with the vertical stretch of the graph, or if it's going to compress the graph. Okay, so just a quick reminder that if a, absolute value of a, is greater than 1, then it's going to be a stretch. And if the absolute value of a is less than 1, it's going to be a compress, which should make sense, right? If I multiply you by 2, you're going to be stretching out. If I cut you in half, you're going to be compressed. You're going to be a lot shorter. All right. All right, so just the order, how we want things. We want you to talk about the inside of the radical first, and then we want you to go left to right on the outside, and I'll do that in the next 3 examples. All right, let's do this. It says determine the starting point on the given function g of x, then list the transformations. So the starting point is what we see on the inside. Ooh, hold on, sorry. What we see on the inside. Trying to get my screen back. There we go. It's what we see on the inside and what we see on the outside put together. So on the inside, there's a 0. And on the outside, there's a -7. So that's our starting point, 0, -7. Let's do that for all of them. For number 4, it's the opposite of what we see. So that's going to be 4. And I don't see anything here. So I'm going to say that's 0. Once again, opposite of what we see. So I don't really see anything, and nothing means 0. And I don't see anything out there either, so it's 0, 0. So those are the values that we consider. All right, so now let's go ahead and talk about the inside first. So we have an x on the inside, which means there's nothing there, so we're not going to talk about it. So we're going to talk about the 2 and then the -7. So we're going to talk about things on the outside from left to right. So the 2 right there creates a vertical stretch, or we'll call it a vertical expansion, another fancy word for stretch of 2. And then the -7 is the next thing we'll talk about, and that tells the graph to move down 7 units. Okay? Now for number 4, the only transformation I see is the x minus 4. So I know that x controls left and right, and I'm not going to believe it. So this one is actually going to tell us to move right 4 units. All right. The only transformation I see is a negative in the front, and the negative is going to be a reflection with respect to the x-axis. So those are the transformations we have. So we're trying to give you, one of each concept so you can kind of see how it plays. It's not our first time seeing it, so it's pretty straightforward. All right, let's go ahead and graph. We have 2 graphing problems, and then you get to start your homework. So here is our first thing. First, what we want to do is we want to think about your starting point, okay? So from here, we have a -4. And then from here, we'll take that as it is. It's -3. So our starting point is -4, -3. And I always write it underneath. And then I'll start thinking of numbers that go in one direction or the other. So I know that -5, I'll think of -5, -6, I'll do -3, and then I'll try to think of, actually I won't do -6. We'll see how that goes, but I'll do -6. Alright, so let's see, when I put -5 inside, I get the square root, I'll do some work here, square root of -5 plus 4 is square root of -1, so I'm already at an undefined here. And I know that if one section is undefined, that whole section is going to be undefined on one side. Okay, so one side will be undefined, the other side will actually have values. So when I put in -3, -3 plus 4 minus 3, well, -3 plus 4 is square root of 1 minus 3. Square root of 1 is 1. 1 minus 3 is -2. So that's my first value, -2. Now, I can go ahead and do -2 as my next value, but here's what happens. When I put -2 plus 4, I get a 2, and I don't know what the square root of 2 is, so I want a number that's going to make that a perfect square. And 0 will do that. So square root of 0 plus 4 minus 3. Square root of 4 minus 3. Square root of 4 is 2 minus 3 is -1. So that gives me 3 perfect points. And you can plug this into the calculator as well just to check it out. But those 3 points will give me my square root shape. So I have -3, -4, -3, -3, -2, and 0, -1. And here is half of the u on its side. Now, for the domain, it says circle the values that are included in the domain. So when I look at it, I notice that -4 is included. -1 is part of it. 0 is part of it. 1 and 2, these are all part of it. The only one that's not is -6 because I don't have a point anywhere there. So just kind of showing you. And then for the range, what are the values? Well, the first time I see a y value is at -3. So that's the first time. There's none for -4 and none for -6. And then it keeps going up. So it's 0, 1, and 3. Those will be part of my range as well. Okay. All right, let's do this one more time. So here's another graph. We have -3 square root of x minus 3. So let's think about the starting point. It's the opposite of what we see here. So that's 3. And what we see outside, which is nothing. So it's 3, 0 is our starting point. One of these sides is going to be undefined. I don't know which side yet. We'll figure that out in just a minute. And so I'm going to start plotting some points. I'll do 4 first. So I have -3 square root of 4 minus 3. That's -3 square root of 1. -3 times 1 is -3. So since I got a nice number, I know that this section is going to be the undefined section. Right? So if this is my starting point, one side will be undefined, one side will actually have points. Alright, so now I got to think of another number that's going to give me a perfect square. 5 won't do it because that'll give me 2. 6 minus 3 is 3. I don't know the square root of 3. 7 minus 3 is 4. And I do know the square root of 4. So I'll do 7. So then I'm going to put -3 square root of 7 minus 3. -3 square root of 4. -3 times 2. And that's -6. So that's my next value that we have. And I just really need 3 points to graph this shape. So I have 3, 0. 4, -3, and 7, -6. And I can already see my shape coming alive. There's my half of a U on its side. Alright, now let's talk about the domain and the range. So my domain starts at 3 and it goes to the right. So -6, -2, 0, 2, these are not part of it. 4 and 5 are the only ones that are within my domain. And for the range, I start at 0 and I go down. So that means -8, there is a point on -8. -5, there is a point there. -1, there is a point there. At 0, there's a point there. But at 2, there's nothing. And at 6, there's nothing. So those two are out. And that is all I have for today's lesson. I hope that was helpful. If you're still struggling, ask a lot of questions in class. Looking forward to seeing you. Bye.